my YouTube channel. In my top interview 150 problem series, today I have picked remove duplicates from sorted array problem. So this problem is in continuation with remove duplicates from sorted array problem. If you haven't checked out this that solution yet, please go ahead and see that video. That is a very small video, and then we can move on to but then you can continue with this explanation. The problem is marked as medium, but this is a very easy problem. You can see here we are given the in this problem we are given the nums array, and in this nums array we will have values with with some unique occurrence and some multiple occurrences. We just have to make sure in the output array we just have to return the only two occurrence of a particular value. If there is just one occurrence, then we have to return the one occurrence only. But if there are multiple occurrences, we have to make sure that only two occurrence, the value is only occurring twice in the output array. And since the array is sorted, we don't have to worry about anything else. We can simply jump to the solution, and we can do the solution using two pointer approach. And in the two pointer, we are going to use, as always, we are going to use I for iterating over the whole array, and k is there to only keep track of the elements we have inserted in the output array so far. Okay, so here for since in the output array, for any element we can have two occurrence of any value. So for initial for initial two elements, we don't have to worry about it, and we can simply insert any value. Sorry, huh? Yeah, so we can simply insert initial two elements. Okay, so for that we can take like this. For k equals to 2, it will simply come into this block, and whenever the insertion in the output array, we are not taking any output array, but we are simply going to override the currently existing elements, and we are going to keep track of that using k index k, this pointer k pointer, and we are doing the overriding in a way that it is not hurting the originality of the array, like the output is not going to get hurt. So we are going to use this smart way of overriding this existing value to the output array. Okay, so yeah, let's see how we are going to do this. For initial and for the value more like for the indexes which is greater than 2 or 2 or greater than 2, we will see how we are going to take the second approach. We are going to move ahead, but let's see how we are going to proceed here. For initial two elements, we don't have to worry, and we are simply going to do the insertion. So when we have, like, let's write 3 4 5 6 7 8. So for I equals to 0, k is also 0, and it is simply going to insert the value here. Because k is less than 2, so it will come inside, it will insert, and whenever insertion is going to happen, the value of k will increment. So when I is 0, k is also 0. But sorry, I don't know what is happening here. Yeah, so okay, so when I is 0, k is also 0, and when the insertion happens, we have I is going to get incremented because it is iterating over the loop. And since the insertion has already happened, k is incremented, and at first position k is also like here, and we are trying to see what we can insert at first position. So for initial two elements, we don't have to worry about, since we can see that k is less than 2, it will come inside this block, it will insert the value 0, and it will increment. Now we have to keep in mind that for k, which is for k greater than 2, okay, for k greater than 2, after the insertion we are going to increment the value here. Okay, so now after the insertion, the value here, the value is 3. At this point, we have to see that for any value which is greater than 2, for the value which is greater than or equals to 2, here we will check that since the array is sorted, we will check whether the value we are trying to insert is equals to or not equals to the value 2 indexes prior to it. Like in this case, if you see at initially the initial two two occurrences of 1 is going to get inserted, but at third index, third occurrence of 1, it will check whether the current element I am trying to insert is equals to the value two indexes prior to it. If that is the case, then the insertion is not going to happen. So let's quickly see. At third index, we have the value of k is also 3. Sorry, I am at second index right now only. So at second index, the value of k is 2 and insertion is going to happen, because nums of I, at nums of 2, the value here, it is going to check the nums of 2 is 1, and it will check k minus 2. So value is k, value of k is also 2, so 2 minus 2 is 0. So nums of 2 is going to get compared with the nums of 0. So 0 is not equals to 1, so insertion is clearly going to happen. And similarly, at it will increment and it will come at third index. At third index as well, we have 1, and it will check after the insertion, the value of k got incremented to 3, from 2 to 3. So 3 minus 2 is 1. At nums of 3 is equals to nums of 1. So no, right, nums of 3 we have 3, sorry, nums of 3 we have 1, and nums of 1 is 0. So 1 and 0 is not equal, so insertion is going to happen here as well. But after this, we will see how we are going to proceed. Okay, at this point, the value of k and I both will increment. After every insertion, the value increments. Now it has come to this value, nums of 4. We have 1 here, and at it will check the nums of 4 is going to get checked with 4 minus 2, 2. So nums of 4 we have 1, and nums of 2 also we have 1. Nums of 4 is going to get nums of 4 here. The nums of 4 is going to get compared with nums of 2. We have 1 at this position. At this point, only I is going to get incremented, and k, no insertion is happening, because it will not come inside this block. Whenever it doesn't come inside the block, we ignore the value. We don't increment the value of k, just the value of I gets incremented. And after this point, you all will be able to solve this problem easily. Okay, so insertion is not going to happen the same way. It will come, and the same thing is going to get followed here as well. At nums of 6, it will check whether the value at nums of 4 minus 2 at 2 is equals to nums of 6, right? We have nums of 2 is equals to nums of 6. At this point also, insertion is not going to happen. It will not come inside if block. The I value of I is going to get incremented, but the value of k we have still is 4. At 4, we are waiting to insert something. Now at nums of 7, we have 0 1 2 3 4 5 6. Sorry, so sorry, it will check with at I have messed up with the value of indexes, but I hope that you have understood the solution that I'm trying to run here. Okay, so at index 6, it will check whether the value at 4, at index 6 we have 2. Okay, so at index 6, it will check at 4 minus 2. So we have at index 6 we have 2, and at index 2 we have 1. So when it will compare it, 1 is not equals to 2, so it will come inside this if block, and it will insert the value at fourth position. Okay, the value at fourth position is going to be at 2. And now this is going to get incremented, this is also going to get incremented. At seventh position, it will check whether the value at seventh is equals to or not equals to 5 minus 2 at third. So 7 and third, there is no comparison. 2 is not equals to 1. So here as well, 2 is going to get inserted. Okay, and similarly 3 and 3 is going to get inserted. There is no clash. You can move ahead and solve the problem on by yourself only. So this is a very easy problem. Everybody, please try and do solve and do dry run. I have taken the bigger example so that you can you yourself will be able to solve this. The all the elements, all the cases of this has been covered in the like all the cases of this has been covered in this example only. That's why I took this example. Please go ahead and solve this problem. Now let's try to I have already explained and I am going to write the same things only. We will initially take the value of k as 0 for loop. We will take the I pointer and we will iterate through the whole loop. Okay, and I plus plus. For edge cases, we are going to take the value of k. If for the value of k less than 2, we are simply going to do the insertion, and for the value more than k, we are every time we are going to check whether it is nums of the current element we are iterating should not be equals to the value at two positions prior to the value of k, and then we will simply going to insert, and and in the end we will return the value of k, the value of length, final length of the output array. So let's see, it is accepted, and solution is also accepted. So this is a very easy problem. Let me quickly give you a summary of whatever I have explained till now. We have taken two pointer, I scans through the array, k marks the next valid position. We check whether we compare the value of nums of I with the nums of k minus 2. If they are different, we exclude the current element. If we skip that, and if they are if they are same, then we skip that, and if they are different, then we insert it. And the time complexity, clearly it is being done in one pass, so it is big O of n only. Thank you for watching. Keep learning, keep coding.